Hello students. So in the previous video we looked at decimal expressions of rational numbers, expressing the rational numbers in decimal form. So we continue with the solution of few more problems in this video. Let's take our first problem. Our first problem for the day is 3 upon 13. Let us solve this. 13 divided by 3. Okay, so we cannot divide this straight away because in the divisor we have 2 digits, whereas in the dividend we have 1 digit. So put 0 over here, bring this 0 on. 13 into 0 is 0. 3 minus 0 is 3. We need to continue division. We need to put a 0 over here and a dot over here. Bring this 0 down. 13 3 is a, sorry, not 3, 3 times 13 3 is a, will give us 39. We need a number that is less than 30 or equal to 30. So that would be 13 into 2, 26. 30 minus 26 gives us 4. Once again we put a 0 and bring this down. 13 into 3, this time 3 will go. 13 3 is a 39. 40 minus 39 is 1. Put a 0 over here, bring it down. 13 is the number in the divisor is bigger than the number in the dividend, so we cannot divide it. So we put a 0 and bring the 0 down. So 10 we get. Put another 0, bring it down. This time we can definitely get a number. So the closest possible number will be 13. 7s are, will give us 91. 100 minus 91 gives us 9. Put a 0, bring it down. Okay. Now this time we'll have to take 13 6, which will give us 78. And that will give us 12. Once again we cannot divide this, so we put a 0 over here, put a 0 here, and 13 9s can give us 117, which gives us 3. Okay, then we continue. We put another 0 over here and we put a 0 here. So 13 into 2 will give us 26. 30 minus 26 is 4. Put a 0 here, bring this 0 down here. 13 into 3 will give us 13 9. 40 minus 39 is 1. Okay. Now, do you see a pattern that has emerged or emerging? Have a look. 0.230769, and then it goes back to 2 3 over here. Look at where this happens. Okay, we have 120 minus 117 gives us just 3, and then we put a 0 down. So this stage, at this particular stage, compare this stage with this one over here. See, and then it continues. 30 minus 26 gives us 4. Put a 0 down over here as well, and again 39. And if you continue solving the division, we will repeat all over again this number right up till here. So that is recurring, and obviously since we are not getting a remainder as 0, it is non-terminating. So we can take as 3 upon 13 is equal to 0.230769. We can put a bar on top of it and say that it is non-terminating but recurring. Okay. Why is it recurring? Because this number in the quotient repeats from this step onwards, and non-terminating because the remainder is not equal to 0. So that is our answer for 3 upon 13. Let's go to the next problem. Next problem is 2 upon 11. Let us divide 11 divided by 2. So we'll put a 0 here, 0. Why 0? Because it is not divisible by 11. Not only that, is the divisor has 2 digits compared to the dividend which has only 1 digit. So we cannot divide that. So we put a 0 here, we put a decimal point over here, it will bring the 0 down. Now we can divide 11 ones are 11. 20 minus 11 gives us 9. We bring a 0 here, bring it down again. 11 into 8 will give us 88. 90 minus 88 will give us 2. Put a 0 here, bring it down. 11 ones are 11. That will give us 20 minus 11 is 9. Okay, have a look, the step is repeating now. So it will be 1. If we put one more, let's say 0 over here, it will be again 11 8s are 88, and once again you will get 2 and it will repeat. So starting from the first step, that is from here, it repeats all over again. So we can put over here bar. Okay, so here the remainder is not equal to 0, and in the quotient we find that it is repeating all over again after the first 2 digits. So we can say 2 upon 11 is equal to 0.18 bar, and it is non-terminating because the remainder is not equal to 0, non-terminating, but recurring. Okay, so this was an easy problem. You understood? We need to look for whether the remainder comes to 0 or not, and if the remainder is not coming to 0, we also need to check at the same time simultaneously whether the quotient, the numbers, the digits in the quotient, are they repeating themselves after a particular sequence. You will have a sequence like over in the previous case we had more than 2 digits that were repeating. It was a big number, it was a big division. This is a shorter division compared to the previous problem that we solved. And you see within the first 2 digits after decimal point, the division repeats itself all over again, showing that the quotient is recurring, and also the fact that we are not getting the remainder equal to 0. That means it is not terminating. Let's move to our final problem of this video before we switch to different types of problems in rational numbers. 329 upon 400. Okay. So once again we go to divide 400 divided by 329. Okay. Now it looks like a big number, but in reality it is an easy problem. Let's see how we can simplify this problem. Now we do not know 400 times table over here, so how we'll have to multiply a lot. No, that is not the case. 400 divided by 29. What if you just put your fingers on this 2 zeros and see only the 4? Then how would you divide? Can you find out what number will go with it? Probably look at the first 2 digits. It says 32. What if only 4 was there and 32 was there? What would have been the number that you have gone to divide it with? 8, right? 4 8s are 32. So let us see if we can do the same thing with this. Let's see 400 into 8. What do we get? 400 into 8. 8 0 is 0, 8 0 is 0, 8 4 is 32. So this is quite big a number. Okay. so we don't need that number. But at the same time, have a look. We cannot divide this by this because the number in the dividend is smaller than the divisor. So we put a 0 over here, bring this 0 down, and we get 329 back. Then we put a 0 over here, put a decimal point over here, and now we have got a number that we can divide. Look at this number that we have got, multiplying 400 into 8, and look at the number in the dividend now. We can definitely put this, right? So 400 into 8 will give us 3200, and what we'll get? We'll get 90. This will be 0, right? Now 400 into 90. Now we'll put a 0 over here and we'll bring the 900 down. Now which number will go with 400? Once again, hide the two zeros over here and just look at the number as if it was 4 divided by 9. You would have gone with 2, right? So let us see 400 into 2. What does it give us? 800. So 400 into 2 gives us 800. This would give us 100, right? When we bring a 0 down, next, would there be a higher number than that? I don't think so, because if we hide the two zeros and just keep 10, again it would have been dividing by 2. So 400 into 2 would give us 800. 1000 minus 800 gives us 200. Put a 0 over here, bring this down. Now again hide the two zeros over here and divide 4 by 20. What do we get? 4 5s are 20. Let us check. So we erase this part, our rough work. That was our division. So we'll write that back again. 329 divided by 400. So take the first number, hide the two zeros, take the first two numbers, hide the two zeros. So we get 4 divided by 20. That would be 400. So now 400 into 5. Let's see what we get. 5 zeros are 0, 5 zeros are 0, 5 4s are 20. Yes, we definitely get. So 400 into 5 gives us 2000, and that gives us 0. Easy? So what do we get? We get a terminating sequence. So we can erase this. So that way we can say 329 upon 400 is equal to 0.8225, and the sequence is terminating because our remainder is 0. Alright. So with this we complete problems on decimal expression. I hope you all have understood these problems. Thank you.